Okay, just waiting for the last few people to get settled in. Excellent. So good afternoon, Kotlin Conf. How are you all doing? Yeah? Enjoying the conference so far? Excellent, excellent. So my name is Adele, and it is absolutely amazing to be speaking here today. And I'm not just saying that to be gracious. Kotlin Conf and I actually go way back. This is a T-shirt from the 2018 edition in Amsterdam. So at that time, I'd been helping to organise conferences for just over a year, and I was actually assisting the JetBrains team with some on-site partner support for that edition of Kotlin Conf. And also at that time, I was yet to write my first line of code. I hadn't even opened Terminal before, but I was starting to catch the coding bug by association simply by being around some of the most passionate people in tech. And as luck would have it, I actually won this book at that 2018 edition of Kotlin Conf, Kotlin Apprentice, a book not only just for learning Kotlin, but learning programming from scratch with Kotlin. So I took the win as a sign to take my dream seriously, and I worked my way through it. Eventually, I convinced my boss to take a leap of faith and move me from the marketing department to the engineering department. And the rest, I guess, as they say, is history. And I've spent the last 8 years building my career as both a software engineer and as a conference speaker. So I was beyond thrilled when I got the acceptance mail for Kotlin Conf 2026 edition. This is my full circle moment. So thank you so much for being a part of it. And I'm going to do my absolute best to make sure that I don't disappoint you. Now, who here uses Kotlin Notebook already? So a couple of hands, but not too many. Okay, hopefully I can show you something new. And if those of you that haven't tried it, it is, I think, something that's very nice to add to your toolkit moving forward. Now, maybe a bit of a strange question, but who here has heard of the sport of powerlifting? Oh, quite a lot of you. Excellent. I love me some nerds that lift. And for those of you that haven't heard about powerlifting, that is totally okay. I will take a minute to explain it briefly anyway, just so that we are all on the same page. So powerlifting is a strength sport where lifters try to lift the maximum that they can for one repetition in each of 3 lifts: squat, bench press, and deadlift. Now, if you're not familiar with these lifts, let's just have a quick demo from the strongest women on the planet. So this is a squat. You put the bar on your back and you squat down until your hip crease is below the top of your knee, down and up, just one time. This is Carlina Tongatea. She is from New Zealand and she is the current world champion in the 76 kilo weight class. That is 231 kilos and a world record on the bar. In the bench press, you lower the bar to a dead stop on your chest before extending your arms to return to the starting position. Now, this is Agata Shitsko. She holds the bench press world record in 3 weight classes. Here she is in the 69 kilo class, and that is 158 kilos on the bar. Now, in the deadlift, you simply pick up as much weight as you can from the ground, bend down, grab the bar, use your legs and butt to return to the standing position. This is Heather Connor in the 47 kilo class, deadlifting 212.5 kilos. That is 4.5 times her body weight. Now, this is a pretty simple sport, really. Lift heavier circles than your competitor in a very specific way. But when it comes to analysing the data set, there's some nuances in it that can trip you up if you don't take the time to learn them. Because anyone who has studied at least the smallest amount of statistics knows how easy it is to mess up if you're not careful with what you're doing. And the most battle-tested way to protect yourself from such mistakes is to know your data set really well. And well, I know powerlifting, but I want you to keep in mind today as I explore the core concepts, how you might be able to get more insights out of the data that you have available to you in your work, a domain I'm sure you also know really, really well. So for example, with logging, metrics, events, or even just your database. Because this is what I really liked about Kotlin Notebook from the get-go, is that I could connect directly to an existing data source and get my answers to my burning questions in a short time. No Python, no new stack, no manipulating CSVs. Now, nothing against the Python ecosystem. Some of my best friends are Python developers. For example, Eli here. Funny story, Eli actually saved my life, so feel free to come up to the session and ask me afterward how they did that. Anyway, Eli's life-saving capabilities aside, I'm just not that interested in installing and learning a new language stack in order to do some basic data analysis. Like, I just want to know how many users are using the latest feature and create like a nice plot for management, you know? So with that in mind, let's open up IntelliJ and see how easy it is to get started. So the foundation of this presentation is the Project Kotlin Notebook talk, which is available on my GitHub, Adele97. I will give you a QR code in a second. So this project contains a Docker Compose file, a data importer, and a CSV with some data, so you can easily get up and running with a populated database. And I've run all of that already, so if we switch to the demo, then we are good to go. So firstly, the Kotlin Notebook plugin comes bundled already with IntelliJ Ultimate, so you should just have the file type available to you if you go new Kotlin Notebook, and then you just put like my notebook, and then you go, nah, I'm good. Okay, so the extension IPYNB, that stands for IPython Notebook, but today it's just the standard file format for Jupyter Notebooks. And well, like a Jupyter Notebook, well, it's an interactive document where you can write code, markdown, text equations, and visualizations all together. So it allows you to run your code step by step and see your results and iterate as we go. So just not to tempt the conference internet too hard, I've already run this cell where we import our dependencies. So at the top, I've got DataFrame, which is a abstraction for working with structured data, and Kandy, which is a plotting or visualization library. Now, defining it like this with use latest descriptors means that you get the latest versions of everything, but of course you can also set a specific version as well if you wish. Now, this use notation with the percentage, that's called cell magic, and that gives you a lot of neat functionality, but sometimes the thing you need isn't available, so you actually have this option to do @file depends on notation where you can import Gradle dependencies. Now, I've done that here to access a QR code library, so this is actually the QR code to the repo for this project. So I'll give you a sec to scan that one. The enshittification of the internet is the reason I put this bit in the presentation, by the way. It was not easy to get a nice, clean, free QR code generator. So while you're scanning that, I'll just bring your attention down to this helper class here, which is actually in this project, in the utils here. So in that class, I just have a helper function that I will be using a lot to create a JDBC connection to connect to the Postgres database. So it makes the connection to JDBC, it executes the query, converts the query to a data frame, and then it closes the connection. So this is a handy little function or class, helper class that we have. So the next thing is I've declared a function as an expression. So it takes two parameters, start year and end year, which acts as placeholders in our query string. So this means once we've run it and the query is saved to our notebook state, then we just have a template for different queries. It's trivial to just change the years that we're interested in looking at it. So we can just call this like any other function, and this just really, again, supports our ability to iterate very, very fast. Okay. So now that we're set up, I think that it's a really good moment to ask ourselves what we actually want to achieve from analysing the data. The data analysis tools that we do have today, they're just so powerful and simple to use. that it can be easy to lose sight of actually what we're trying to do. You know, we can run some commands and we can get a result really, really fast, but like, how do we interpret the output? How can we be good data science practitioners even if we are only just starting out? And it means that we need to stay in our statistical lane. And I'll leave you with the wisdom of Homer Simpson while I take a sip of water. And you can like laugh at Homer's like naivete. I did hear some very like loud exhales out the nose, which I suppose is the modern form of laughter these days. Because you can make the data say anything, driven by malice at worst, but driven by naivete at best. So the last thing that I want to do is embolden you to make all kinds of crazy conclusions because the computer said so. I mean, we have enough AI sycophants doing that for us already. We are serious software engineers. So first, a little overview of those statistical lanes. So at first we have exploratory data analysis. This is where we identify patterns and generate hypotheses to guide further analysis. Essentially, what is the data telling me? We have descriptive analysis, where we focus on summarizing and describing the features of the specific data set, aka what has happened. Inferential statistics is where we use statistical tests as a way of determining if there is a relationship between variables. That is why it happened. Next, we have predictive analytics. So using historical data to forecast future outcomes, trying to answer the question, what will happen? And then we have prescriptive analytics, where we recommend specific actions to achieve a desired outcome. What should I do? So we're going to stay very much in the lanes of explorative and descriptive analysis, steering very much clear of the predictive element as we keep our focus on what's in the data already. Now, that might seem a little bit boring, but you can actually get really, really far with a good understanding of the data. So let's start getting to know our data set. So our data set is from openpowerlifting.org, which is an open source collation of competition data from all over the world. And the fact that it is competition data is a very good sign for our analysis, because compared to self-reported data, for example, the information is captured as it happens in a consistent environment that upholds the technical rulebooks of the sport. It doesn't rely on like memories and vibes like self-reported data, for example. So we don't have to use methods like benchmarking or cross-referencing with external verified data sources, because this is the verified data source. So if we go back to our demo now, we have run our query here to fetch the data. So we've done that, we run our query, and we run data.size. We see we have 86,000 matches for the year of 2025. So the first thing that I like to do when I'm set up is to take a look at the data for the first time, is to run the head command. So this command simply prints the first few rows of the data set, and I'm just going to have a look at the first 20. So we have a look and we say, yeah, name's a string, that kind of makes sense. We've got sex male, lifting, male dominated. We have the event, and then the equipment type. This all kind of makes sense. And if we scroll across, excuse me, to squat 4, we see that there are a large number of null values. And this is actually perfectly fine. So squat 4 is taking a fourth attempt is actually very, very rare in powerlifting, and actually doesn't contribute to the total. So for most analyses, you can actually leave squat 4 out. So that's a handy thing from the domain to know. And now if we keep going and we go to country, we can see actually that some of them are null, which is a little strange because you think every event is held in a country. Maybe that should be mandatory. The reason that some of these are null is because this is lifter country, and it's only included if the lifter country is actually known. So the one that is not null that we would expect is meat country. So indeed, these all say Italy. We don't see any nulls there. So there's nothing really new or groundbreaking here, but just with a visual inspection of the data, we can start to get a feel for what it's like. So the next thing that I like to do is to run the describe function. So it will return a data frame with general statistics of the value columns. But what I'm interested in here is just these first four. So the name here is just the name of the column in the underlying data schema. We have the type, which is in the Kotlin, familiar Kotlin nullable types. So we can see that name, sex, event, and equipment are mandatory. And if we were to cross-reference that with the documentation of this data set, that would be consistent. And if we scroll down to country, then we will see that country is indeed nullable, but meat country not nullable. So we should expect a value in every column there. Then we have the count column that matches our size, so that's great. And if we scroll back up to name, we can see we have 51,000 or so unique name count. So name is actually the identifier in this set. So name, you think, oh God, are there that many unique names in lifting? It is a unique identifier. What they'll simply do is just add a number after your name if you're like the second Adele Carpenter. So far, there's not, it's me. And so, but we can see here with that difference of about 30,000 or 25,000 that non-negligible number of lifters have actually done more than 2 or more meets in 2025. So as an example, we can take a look here at Amanda Lawrence. Amanda is an absolutely phenomenal lifter in the 84 kilo class. She's been dominating that for years now. And so we can see here that she has that number 1 next to her name. And so if we scroll across, so a common thing you might want to do when you're analyzing data, and which Kotlin makes or DataFrame makes very, very simple with the operations fill NA and fill null, is you might go, oh, well, this is strange. Her weight class is 84. We've got her weigh-in weight. So why don't we just impute that value and make that as 84? And that could be a very reasonable thing to do for most analyses, but you might not always want to do it, because the reason that this number is null is because this particular meet was a points-only meet. So what that means, it's a smaller meet, and you don't compete against people in your weight class. You actually compete against all lifters. So what they use is a formula between your body weight and the weight that you lifted. They calculate a point, and then you can compare those points and compete with each other. So for that meet, that's why her weight class is a null. It might not affect your analysis meaningfully, but these are the kinds of things that it helps to know up front. So if you decide to fill null, you're doing it with intent. So we keep scrolling across. Now, Amanda is phenomenal, but she still has to operate by the laws of physics like the rest of us. So lifting a negative weight, though, what does that mean? How can you lift a negative weight? So the convention in the data set is that she attempted 250 kilo squat, but she missed it. And that's an important thing to know. It's also important, for example, if you are trying to calculate the total, for example, that you don't just blindly add everything together. You have to take only the ones that are above 0 and add them together, for example. So we can see here that she unfortunately missed 250 kilos. I mean, fine. You had a go. The fact that it was on the table is amazing. But she did make 240 kilos. And then if we scroll across to her best squats, we can just verify visually that the data set correctly points out that 240 was her best squat. So now if we go through and we add 240 for her best squats, and we add 135 for her best bench, and we add 269 for her best deadlift, we should get a total of 644, which the data set also gives us. So running these like cross validation checks and verifications, they can help us get to know the data set a little better and maybe spot some errors, because, you know, we are human. There may be errors in the data, even if the data set is really, really high quality, such as this one. So it doesn't really matter that quirks like this exist in the database at all or in the data. It's actually to be expected, and we should spend some time reasoning about these quirks and making conscious choices. Because then we can actually have confidence in our conclusions, and we can be able to defend any maybe insights or recommendations that we may have. So, now I'm going to move on to the Kandy plotting library. So once we've got our data set, hang on, let me just go back, I think. Here we go. Yeah. So we have a nice mental model of our data set now, and we have run our verification checks. So we're actually ready to pose our research question. But before we do that, now I want to introduce you to Kandy and some things to consider when choosing an appropriate plot. So here is the documentation now for Kandy, which is an open source plotting library for Kotlin based on the Let's Plot visualization library. Data is nice, but seeing is believing. And Kandy helps us turn rows and columns full of numbers into actionable insights. So as we take a quick scroll now through this documentation, you can see that Kandy is quite extensive, providing the most common visualization types. So I certainly encourage you to go through the docs, and in particular, the data examples provided for each visualization type, because that will give you a good feel for the types of data suitable for each plot. But I think I am going to maybe disappoint you a little bit when I say that simple is usually the best. Now, why is that? Because you want your visualizations to tell a story, and you want that story to be as easy as possible to digest for your viewers. Because just as we build software to provide utility to our users, we build visualizations to provide a digestible story to its viewers. So let me give you an example. So when I first started out learning data science with Kotlin Notebook, I started a blog called Powerlifting in Data, and there I tried out a few different chart types. So this is from the second blog that I ever posted. I made a stacked bar chart showing age participation by decade. And it's a nice enough looking chart, but it's difficult to quickly pull out the insights. The easiest thing to see is maybe that just over half of competing powerlifters are under 25, and that's sort of been pretty steady over time. We see a little bit of a dip in the 90s and noughts, but it's really only clear when we add this line on top. And other than that, it's a little bit tricky to pull anything useful out of this visualization. Whereas if we compare it to this chart, where I've done some extra processing with DataFrame to calculate the average annual growth rate over a 10-year period, we can see that the story's much clearer, right? You know, we don't have to squint and tilt our heads and like hold up our thumb, you know, to see what's happening. We can very clearly say that the fastest growing age group is the 21 to 25-year-olds. And the purple dotted line here is simply the average annual growth rate across all age groups. So without much visual inconvenience, we've provided a baseline for interpreting the data, and we can easily see which groups are growing above or below the average rate. Now, for a later post, one of my readers suggested that I take a look at the highest total posted by weight class and how that had changed over time. Now, this was a little bit tricky because I had 17 weight classes to compare over multiple years. And so in the end, I decided to confine the analysis to the last 10 years, which struck the right balance between identifying the trend and then also being relevant to the dynamics of the sport today. And I further decided to make two charts, one for women and one for men, because this is just in line with how powerlifting is discussed more broadly. And here we have the result. I will admit there is still a lot going on, but the lines are relatively well spread out, and we can see which classes are growing, weight classes are growing the fastest by the steepness of the lines. And with the men and women side by side, we see that the overall totals in the women's weight classes are growing faster than the men's. And that's an insight that might at least be partially explained by this chart, where we see that the once male-dominated sport of powerlifting is becoming decidedly less so. So, armed with this knowledge, we can take a look at our research question, which we will spend the last part of today's session looking at. So, in a powerlifting competition, each competitor attempts 3 lifts: the squat, the bench press, and the deadlift. And they get 3 attempts per lift for a total of 9 attempts. And the heaviest successful attempt for each lift is then added together for their total score. Now, powerlifting wisdom tells us that completing all lifts to a meet to the required standard, aka going 9 for 9, is the best way to have a successful meet. And success in this context usually means maximizing your chances of a spot on the podium. However, there are some very loud voices in powerlifting that love to just yell, "Just send it, bro, go big or go home," before loading like a ridiculous amount on the bar for their final attempt. I mean, remember I said that half of powerlifters are under 25. So our research question is centered around this. Is it really better to go 9 for 9 when chasing a win? Or is that YOLO deadlift actually a good idea? So I'm going to open up the Kotlin notebook again and take you through how we might answer that question. But essentially, our workflow will be select the appropriate data, transform the data so that it can be easily plotted, inspect the plot, and then iterate based on what we find. So go to our next notebook here. All right. So in this notebook, we import our dependencies and the same data access helper as before. And then below we have our SQL query again, which is an expression. And this just supports our ability to work quickly with different subsets of the data. Now this SQL query might look a little bit overwhelming at first, but it's actually pretty logical if you break it down. Oh gosh. Okay. Just 1 second. My markdown seems to have disappeared from my notebook, but that's okay. So what this inner query does is it finds every combination of meet, date, weight class, and division that has at least a certain number of competitors. And then the join then uses that as a filter. So we just can keep the categories that are competitive enough. So having a minimum number of competitors is important for how confidently we can draw conclusions from the analysis. Powerlifting is a niche sport, so it's not unusual for there to only be 1 or 2 competitors in a smaller competition. So by confining our analysis to classes that were actually competitive, we can actually draw better insights on whether 9 out of 9 attempts actually does contribute to a win. Now, of course, you could use DataFrame for the filtering. It is a little bit closer to what we're used to with Kotlin collections. And for this data set of about 80,000, it's probably fine to do your processing in memory. But I just wanted to show that you can leverage your existing skills of SQL that you have as developers, which I think is one of the really powerful things about this setup. Because if you have a very big data source, for example, a system that's been running for years, then you probably don't want to load all of that into memory. You can be selective about what you load and only load what you care about. This is also really good for helping you only load the data you need and maybe leaving the sensitive data in the database where it belongs. So only really pulling out what you need. So building a larger query like this is also one where I would actually be happy to use an LLM. Just ask the LLM for the query that you want, and it can do a lot of the heavy lifting for you. But you validate, that's the important part, what it spits out. So, for example, you can load otherwise unfiltered data for a very small time period and then filter it logically, how you would with DataFrame. And the count characteristics of both data sets should then basically be the same, and that'll just show that you are on the right track, and you're pretty confident then that your SQL query is doing what you expected. Now, I won't go through that today, but there is a notebook in the repo where I have done such an analysis, and it did actually help me not only improve the resulting query, but also my understanding of SQL and also the underlying data set. And sure, it might seem a bit redundant or overkill, but I'm just showing you that there are different ways that you can go about it. Because with a real-world data set, there are no predefined answers. You need to continually assess your work and figure out alternative ways to verify things. And this is part of the way of working. You know, you can do all of this stuff pretty easily. Iterating is fast, but you have to verify your work as you go and use your best judgment in order to have confidence in your answers. So we're going to go on to our next cell here now, where I have defined an interface called lifting data with the data schema annotation. So this allows us to use extension properties, which are fully typed and checked at compile time by the compiler plugin. So this again makes data analysis feel more natural to us as Kotlin developers, because the compiler has got our back in the way that we are used to. And we can opt out of the stress of, you know, string accessor, dynamic typos, only fail at runtime type hell, you know? So all these fields in our lifted data, except the last one, successful lifts, are in the underlying Postgres table schema. So I added the successful lifts so we could use it later, because what's really cool about data schema is that it's a partial contract and there's no validation on load. So it's totally fine to add fields that don't exist yet. It just simply tells the compiler to generate the typed accesses. We can always just add more fields as we need them, or if we know what we might need, we can add them up front, and the compiler is there for us, ready and waiting. So we build the query now, and we run it against the database, and I'm defining a competitive weight class as a weight class with at least 3 competitors in it. So basically a full podium. And then we check how many results that we have. And we have 48,000 or so results. So remember that we, in total for 2025, had about 86,000 entries. Now we only have around 48,000. Sorry, I may have misspoke. So that means that we could have maybe been a little bit too ruthless in our filtering. We've lost like just over half or 2/3. But there's a couple of reasons why I'm confident that this is fine. So first of all, local meets outnumber the bigger regional meets. So you probably just have a lot of meets where there's just not that many competitors, particularly in the smaller weight classes. So that's, you know, one reason that we might see a drop. Also, I've only filtered for full power meets only. So what does that mean? Well, that means that you've got a squat, a bench, and a deadlift in the competition. Bench press only competitions are a thing, so are deadlift only competitions. Now we're looking for competitions where you did 9 lifts. Those events only have 3, so it makes sense to totally filter those out. So now we come to sort of the real crux of what we're trying to do here, and we're creating a function where we add the number of successful lifts. Okay. So this function here takes the data frame and it takes a first place only Boolean, which is defaulted to true, because what we're looking for is the number of the successful lift count of the winners. So we take the lifts, so the first, second and third squat, bench and deadlift, and we count those, and because we know from our data set, if it's below 0, then they missed it. So if it's above 0, it's successful. We filter out an edge case here, and then we have this group by an aggregate. So then we group the lifters by their successful lifts, and then we rename that into a column called count, and then we get the actual count of each the number of lifters that made the number of successful lifts. We then filter for successful lifts being 3 or more. Sometimes, in especially smaller competitions, if you miss squat, for example, they'll still let you bench and deadlift. It's not really an official result, but it's about community and participation. So we filter those ones out. So now if we run that function now, we get a nice, neat little data frame that's ready to be plotted. And it has our count of successful lifts. So remember, we're saying, does 9 for 9 contribute to a win? Or do we see the most winners there? We plot this. We see that the most winners were actually in the 8 for 9 group. And we'll make that look a little bit prettier with the Kotlin styling. So in Kandy, you can use styling in quite a declarative way. We are short on time, so I won't go through that, but this is, of course, all in the repo online. So we set our own font, we set a heading, we set some custom colors. And so, yes, we see that here, that we said the most winners in the 8 for 9, the making 8 for 9 successful attempts. And this did puzzle me for a minute, because I did honestly expect there to be a relationship between the number of successful attempts and the likelihood of a win. And then I realized that lifters that go 9 for 9 are actually in a pretty select group. It's certainly not the most common outcome that I've seen when I've been at a powerlifting meet. Because a very easy mistake to make when analysing the data is failing to take into account the impact of differences in cohort size when comparing outcomes amongst groups. So let's take that into account now. So we're going to run the same function that we declared above, but this time we're going to set the first place only Boolean to false, which means we're actually getting all lifters now. And so now we have our all lifters data frame. The grouping and everything that we did is exactly the same. So we've been able to just make one change, iterate really fast. And so what we do then is we create here a combined data frame where we renamed the count from the winners data frame into winners and the count from the all lifters data frame into all lifters. And then, crucially, we add a brand new column called ratio winners where we divide the number of winners by all lifters to get the ratio. So we basically find out at every level of successful lifts what percentage of those people in the data set actually had a win. And we get a little hint at it now if we look at the raw numbers, but seeing is believing, as I said, and we see that actually we do see what we expected. We do see a clear trend there that if you go 9 for 9, the lifters there have a higher chance of a win. So to be more specific in the language, so 24% of lifters in our data set that went 9 for 9 had a win. 21% of lifters that went 8 for 9 had a win. And 18% of lifters that went 7 for 9 had a win. And we can also then use maybe plot grid, which I think is a very nice feature. And we can see them side by side. So, now, does this mean that our advice to lifters should be play it super safe, load the bar with the minimum allowed, guarantee yourself a 9 for 9, and then you have a higher chance of winning? Absolutely not. I mean, it sounds really silly when you say it like that, but people interpreting data make that mistake all the time. X and Y are related, so if I gamify X, then Y is more likely to happen. X is only part of the story. The relationship between X and Y depends on all other things being equal. So what are some reasons that we might see more winners in the 9 for 9 group? Well, this is where data science becomes a little bit of an art as we use our domain knowledge to come up with alternative explanations. And these explanations might then form the basis of our next research question. So, for example, powerlifting, like many sports, is a mental game as much as it is a physical one. So, building momentum and confidence as you successfully complete more lifts can boost your performance in later lifts. It takes nerve to come back after failing your opening squat, for example. Mental effort that could be better used in making a higher third attempt than scrambling to just simply make your second attempt. Ask me how I know this. So, another reason could be fatigue. So, making a lift takes effort, but struggling and missing a lift actually takes more effort. Powerlifting meets are long. You want to conserve your energy as much as possible as you make your way through the day, and that so that you have enough energy in your reserves to really give everything that you have in that last deadlift. Now, before we recap and close out, there's one final point that I do want to make, which I've hinted at, but I think it's worth covering a little bit more detail, and that is the importance, again, of having a quick and iterative workflow, because we can run multiple scenarios quickly, test assumptions, get feedback, and that helps us build an intimate knowledge of our data set. Because in data science, iterating quickly is of more importance than your code being production ready. It's okay to cheat a little and write code that maybe you're a little bit ashamed of. If it helps you iterate quickly, then that is an absolute trade-off that's worth making. You know, be a little bit ashamed, iterate quickly. That is a good trade-off to make. So, quick recap before we close out. So, Kotlin Notebook is an IntelliJ Ultimate plugin that supports an iterative data science workflow. So you can mix executable Kotlin code with text, results, and visualizations. With the plugin, you can create the notebook with the IPYNB extension, just like you would any other package, class, or file. You can directly connect your database using JDBC and run SQL query to load only the data that you need. You can import external dependencies and modules from your project into the notebook. Data science is something that's best learned by doing. So find a data set in a domain that you know really, really well. Even a high quality data set is gonna be a little bit messy and a little bit quirky. Get to know it, iterate quickly, challenge your assumptions, think of different ways to cross-check the data. It's okay to drop nulls and A's and impute values, but you need to know why you are doing that and defend any choices you've made and what impact those choices could have on your results. Next, don't think that you need to go all in on predictive or prescriptive analytics. You can actually get really, really far with descriptive statistics as long as you apply the basic methods well. We got pretty far with exploratory and descriptive statistics today, and our next step would probably be inferential statistics, where we run some statistical tests on the data. That would unlock another level of insights. But often a sound knowledge of the past and present is all that we need. The Kandy plotting library offers a nice selection of visualizations. Play around with them, learn what data types and relationships suit which, and cannot stress this enough, go for the simplest visualization possible to get your desired point across. The viewer shouldn't have to have to work too hard or risk being easily misled when interpreting what you've presented. Oh yeah, and it's probably not the wisest idea to load up your bar extra heavy for your third attempt deadlift. My name is Adele, and thank you so much for your time.